Hi, my name is Michael Benman and I'll be participating in Challenge 2016. And today I'm going to be explaining one of the problems from our placement test for calculus. I chose to explain number 7, where we are asked to find the limit as x approaches 1 for 1 minus x times the cosine of pi over 2x over the natural log of x plus 1 minus x. As with any limit problem, the first step is to plug in the value that the variable will be approaching. However, when we do that in this problem, we find that we have an indeterminate form of this fraction, because the natural log of 1 is 0, and 1 minus x is also 0. In order to get through the problem, the main rule that we're going to need is L Hopital's rule. Now, what L Hopital's rule tells us is that whenever we're trying to find a limit and have an indeterminate form of a function, then all we have to do is simply derive the numerator and the denominator in order to get a new fraction and use that to find the limit by plugging in whatever the value of x will be approaching. Now, in order to go through L Hopital's rule, there are two other things that we're going to need to know. First, we're going to need to know what the product rule is. Now, the product rule is used whenever we're trying to find the derivative of two different functions, which in this case we're going to have to do that. In order to explain that a little bit more, I have a simple example here. Here we have f of x is equal to x plus 1 times 2x plus 1. So the first step would be to write the two functions down. So here we have x plus 1 and 2x plus 1. And underneath, I usually write the derivative of those two functions, in this case 1 and 2. Then you use this layout to simply multiply and add them together. So first we have 1 times 2x plus 1, and we're adding the value of x plus 1 times 2. The other rule that we'll be using to help us differentiate this problem is called the chain rule. And for example, we have f of x is equal to the sine squared of x. So the derivative is basically finding the derivative of the main function, and then in this case, since we have another function inside, we had to multiply that by the first derivative. So first we have sine squared of x. So as usual, we take the 2 down to the front and we reduce the power that sine is. So we have 2 sine of x, and since sine is inside of that function, we also find the derivative of that, which is cosine. Now that we've derived both parts of the function, both the function itself and the function inside of it, we can now see that f prime of x is 2 sine of x times the cosine of x. Alright, now we're ready to actually solve the problem. And here I have a layout of each step in different colors so it's much easier to follow along. First, up here in black, we have the original problem. And as we already know, when we plug in 1 for x, we're going to end up with an indeterminate form of this fraction because the denominator is going to be 0. Next, we're going to move on to the blue, where we're going to start differentiating the numerator and the denominator of this problem. So we can see that in our numerator we have two different functions. So we're going to be using the product rule to differentiate this. Here, starting in the blue, I have 1 minus x and the cosine of pi over 2x. The derivative of 1 minus x is going to be negative 1, and here for the cosine we're going to be using the chain rule as well. So first we know that the derivative of cosine is negative sine of pi over 2x. And now we have pi over 2x within that function. So we need to find the derivative of that as well. So we would multiply by pi over 2 and end up having negative pi over 2 times the sine of pi over 2x. With that, we can cross multiply and add the two values together. Over here, we have the new numerator, and the denominator now, we can derive the natural log of x, which is 1 over x, and this function will derive to 0 and negative 1. Now that we're done with the blue, I thought it'd be a little bit easier to rewrite this equation right here. Now, as you can see, when we plug in 1 again, we're going to end up having 1 minus 1. So that means we have to use the L Hopital's rule once again. First, we're going to start with the numerator. We have this function that's by itself, so we have negative cosine of pi over 2x. When we derive that, the derivative of cosine is negative sine. So then this is going to become a positive, and we have to use chain rule as well. So we're going to end up with pi over 2 times the sine of pi over 2x over there in the green. Then we're going to use the product rule again for these two functions right here in green. We have 1 minus x, whose derivative is negative 1, and then we have negative pi over 2 times the sine of pi over 2x. Here we're going to be using the chain rule again. So first we have negative pi over 2 times cosine, because the derivative sign is a positive cosine, of pi over 2x, and using chain rule we're going to have to multiply it by pi over 2 once again. So in the end, for this one derivative, we're going to have negative pi squared over 4 times the cosine of pi over 2x. And then we're going to cross multiply and add using the product rule, and we're going to end up having the second part of this equation over the denominator, which we're also going to be deriving. So when we derive x to the power of negative 1, we're going to have negative x to the negative 2, which in this case is negative 1 over x squared. Now that we've reached this point, we can once again plug in 1 to see if we end up having an indeterminate form of this fraction. And we can see that when we do plug it in the denominator, we're going to have a value of negative 1, not 0. So now we can finally find the limit. Here in red is what you get once you plug in 1 for x. So in the end, we have pi over 2 times the sine of pi over 2, which is 1, plus pi over 2 times the sine of pi over 2 again, which is 1, plus 0 over negative 1, and we work it out, we end up with negative pi. So the answer to number 7 for our placement test for calculus is negative pi.